Welcome to CHA-Devs. Thanks for coming out today. My name is Andrew Rogers. Excited to hear a little bit about Kubernetes today. Before we get started, wanted to see if there's any community announcements and then make a few announcements ourselves. Anything coming up? Obviously, DevOps Days, November 12th, 2019, here in Chattanooga. Get your tickets now? Okay, yeah. Early bird? Say what? Oh, wow. Early bird, almost half off tickets. Get your tickets now. Anything else going on? Next Thursday, we will not do CHA-Devs here. Signal Centers, in partnership with UTC and a few other local organizations, is hosting an Accessible Technology Summit. And they have a special keynote speaker, Haben Girma, who is the first deaf-blind graduate from Harvard Law School. And she'll be talking about accessible technology and accessibility in general. And there'll also be some really great panels with some of Center Center's folks about accessible technology. So I think they still have tickets available for that. It's at UTC, so please get a ticket and go to that instead of this next Thursday for lunch. With that, turn it over to our speaker.
I'll do a little bit more of a pitch for DevOps Days because I love DevOps Days. Was anyone at DevOps Days last year here? Okay, a few of you. There should be more because it's an awesome event and it is really affordable. It's around half off right now for our blind bird pricing of $35. That lasts for a bit less than a week, I think. And it's a really great event. We're going to have hopefully even better speakers than last year. We have some really great ones that we're almost ready to announce, hopefully. And I'm really excited about this event, November 12th. And also, we're looking for some local speakers. So if anyone's interested in speaking at a conference like this, definitely let us know. Getting into the talk a little bit, you're going to see slides that look a bit like that. And that's because I am shamelessly using this as a warm-up. I am trying to present a version of this talk in a couple weeks at KubeCon, which is the Kubernetes conference. And I am really, really hoping that I can get some feedback out of this for areas that need some improvement, that are slow, boring, confusing, whatever it happens to be. Do let me know. And when you see lots of slides that have this branding, just pretend that we're all at KubeCon together having a great time. So with that said, today's talk is Smarter Kubernetes Access Control. And that's a simpler approach to Auth. And for those of you who aren't familiar with me, my name is Rob Scott. You can follow me at Twitter at Robert J. Scott or on Kubernetes Slack. And also, I work for an awesome company called ReactiveOps. We're a fully remote company that does Kubernetes all day, every day. If you're looking for help with Kubernetes or you want to work with Kubernetes, we're hiring and we're accepting new customers. So in both cases, reach out. I've really enjoyed my time at ReactiveOps and would love to talk to any of you about it. So the outline of today's talk is going to be in 4 different areas. First, we're going to work through some challenges of authorization. And this isn't necessarily Kubernetes specific, but they're things that we've seen at ReactiveOps. Now, at ReactiveOps, I work with a whole host of different organizations and help them deal with the hard parts of Kubernetes. And one of those is authorization. And so we're going to go through some of the challenges of authorization we've seen across lots of different organizations of different sizes. And then if you're not as familiar with Kubernetes, or especially with RBAC, we're going to do just a quick recap of the different terms, the different terminology, so that the rest of this talk is going to make sense. So we'll go through a quick recap of everything that is Kubernetes RBAC. And that's RBAC is role-based access control. So it's all about authorization inside Kubernetes. And then most of our talk is going to be spent in 2 different areas. First, open source tools that help us understand what's going on as far as authorization inside Kubernetes. And then once we can actually understand authorization in Kubernetes, we're going to switch that up, and we're going to spend some time looking at how we can better manage and approach Kubernetes authorization. So once we understand it, We want to actually have a good workflow for managing it. So first off, authorization is challenging. I don't think this is unique to Kubernetes. I think this is something that we see in just about any authorization system we ever have to deal with. And one of the reasons is that authorization systems often feel either way too complex or way too simple. I know you've probably interacted with a system where you get an access key, as an example, and you can do absolutely everything. There's no way to give someone just partial access to a system. You give them everything or nothing. And that's really frustrating sometimes because you don't want to give someone root access to your account. On the other hand, there are other authorization systems that allow you to specify every little bit of access, and that can get overwhelming because you don't really understand, well, should I give them this or that? Or it's very hard to do this kind of piecemeal approach, and sometimes the same system can feel too simple for someone and too complex for someone else, so it's really hard to find that right balance. And unfortunately, authorization is something you only really notice when it's getting in your way. You don't really notice an authorization system that's working because it's letting you do what you need to do. But when it does get in the way, you get really frustrated with your authorization system. So it's kind of in a hard place to win. You either don't see it and don't think about it, or you do see it and get annoyed by it. And unfortunately, even the best authorization systems can be difficult to understand. They get really complicated. And even perfectly designed systems, there's just so much that you need to understand, it can get complicated. So, on that note, authorization gets really complicated. Here are some questions that anyone looking at any authorization system is going to ask. How do I know what I'm authorized to do? How do I know what someone else is authorized to do? How do I even know who has access to my system? How do I scope that access properly? And my favorite, how do I even know I'm not missing something? How do I know that I've tried my best, but what if I'm not just missing something obvious here? And that's the whole purpose of this talk, is to go through authorization in this example, Kubernetes, and try and answer these specific questions and provide you with tools and approaches that can make this a little bit more manageable. So, unfortunately with authorization, even the best intentions can still end in failure. Organizations start with highly granular policies. They have these great initial intentions of, we're going to do this perfectly. We've messed up before, but we're going to do this perfectly. We've all been there. But then at some point, you have a coworker that really needs to access this one thing. And you make this one little temporary exception, just for now, because they really need to access it right away. And then, well, that happens again, and it might happen again. And at some point, your authorization system is just composed of a whole bunch of temporary solutions that, of course, never ended up being temporary. They just last forever and ever. I don't know if this sounds familiar to anyone else, but I've definitely seen it and done it. So that's it. Kubernetes on its own, though, has some unique challenges. With Kubernetes, we have this interesting idea that it doesn't actually have users and groups itself. It doesn't actually manage users and groups inside Kubernetes. You can't use kubectl git groups or users. That's just not a thing. Instead, there's an authentication system that when you authenticate into Kubernetes, it's going to provide you with a user and group. It's going to specify what your username is and potentially what groups you're a part of, and the authorization system works with that. So as an example, you can do that with AWS. AWS has a tool called AWS IAM Authenticator. It maps IAM users from AWS over to Kubernetes users, and IAM groups to Kubernetes groups. And it's really great, but it means that if you're trying to understand what users are in your Kubernetes system, you can't actually. You have to go up one level and see what users are in AWS in that case, or it could be some other interface you're using for your authentication. So that's part of the power of Kubernetes, is that it's so flexible, but also part of what makes it complex. And finally, Kubernetes RBAC configuration itself quickly becomes difficult to manage at any kind of scale. And this is what inspired this talk. When you're trying to do RBAC for one or two users, it's, well, I can figure it out. But as you start to add more than a few users, it gets pretty complicated. And so what we found is there are ways that we can make this simpler, but by default, it's pretty complex. Okay, so let's move into just RBAC basics. And just for a show of hands, how many of you have worked with Kubernetes at all before? Cool, okay. How many of you have heard of Kubernetes before? Great, okay, sure. So that's great. Kubernetes is, I'm biased, but it's an awesome orchestration tool for containers like Docker containers, and it came out of Google trying to replicate Google's Borg orchestration system. And it's really awesome. It's taken over the world by storm. And RBAC specifically is how you manage authorization inside Kubernetes. So the first term that we have to understand inside Kubernetes is this concept of roles. And roles themselves don't directly grant access to anyone. What roles do is they provide a set of permissions that you could grant to someone. So roles are just groups of permissions that can be granted to someone, but on their own, they don't actually grant that access. So a role is available in a specific namespace inside a cluster, and a cluster role is available for the entire cluster. Now that may not make a lot of sense, but this is what a role looks like inside Kubernetes. So a role in this case, we're going to call it list deployments, and it says, okay, in this API group, allow to list these resources. Cool. I don't know how to get out of that, but, well, whatever. That's a thing. Oh, well. We'll come back to that. All right. So with that said, apps, deployments, you can get and list them. So this is a really simple role inside Kubernetes. The same thing, now, if you pay any attention, you're going to notice like there's almost no difference. This is a role, and there's that namespace field. If we go to cluster role, it's the same thing, it's just available cluster-wide. That's the only difference between the two things. Okay, role bindings. Kubernetes role bindings connect subjects with roles. So this is where you actually grant that access. Roles are lists of permission you can grant to someone, and role bindings connect the two. So they connect users with roles. And so a role binding grants access in a specific namespace, and a cluster role binding grants that access across the entire cluster. So namespaces are little groups inside little sections, let's say, inside a cluster inside Kubernetes, and cluster-wide cluster role bindings are granting access across the entire cluster. All right, so this is what a role binding looks like, and this role binding grants access to our user. We're going to call her Avery, and again, in the namespace development, and it lets her list deployments. And again, a cluster role binding looks basically exactly the same, except there's no more namespace because this is giving her access across the entire thing. Well, this is all well and good, and this is enough to get us access, but hopefully you're beginning to see, well, this is a lot of YAML, in this case, to give someone access. This is a lot of configuration to just give someone access in Kubernetes. One last note that I think it's worth understanding in Kubernetes is you don't have to create all the roles on your own. There are some default roles that cover 99% of use cases for you. There's a view role, there's an edit role, there's an admin role, and there's a cluster admin role. Each has more access. View is read-only, cluster admin is everything, and the other two fall somewhere in between. That's what I'm going to be using. The rest of this talk is mostly demos, and I'm going to be using these roles. So when you see view, edit, admin, and cluster admin, that's what we're referring to. So, really simple example here. We've got our user Avery, and she should be able to edit anything in the web namespace and view anything in the API namespace. So to do that, we need this thing called a role binding that grants Avery edit access inside the web namespace. But hold on, to do the same thing in the API namespace, all this YAML, you actually need to copy it and do the same thing. I don't even know if you notice those differences. I'll go back and forth. So now, instead of the namespace being web, it goes to API, and the name goes to view. So there's a lot of repetition in this configuration, which is nice. It's pretty straightforward, but it does get repetitive at any kind of scale. So let's dig in a bit into how we can actually understand authorization inside Kubernetes. That's all you really need to know about the inner workings of authorization in Kubernetes, but if you're looking at a cluster, how do we actually make sense of who has access in it? And one of the first questions you're going to ask is, can a given user do a certain thing in my cluster? And if they can, why can they? So there's this, kubectl is this, or kubectl, depending on your preference. I'm going to call it kubectl, is the Kubernetes command line tool. And it has this feature that not many people know about that is auth can I. And it's basically allowing you to ask, can you or someone else do a specific action? And in this case, it's can I list pods as a specific user? So if we run this command as Avery, as an example, we're going to see that Avery can actually not list pods, which is surprising because we just gave her all that access where you would think, yeah, she should be able to access that. Yeah?
Is pods in this case just an example?
Oh, no, great question. So pods are this root level concept in Kubernetes that map one-to-one to containers. So a pod is something that runs a Docker container most commonly, but it could run other kinds of containers. But that's, yeah, great question, thanks. So she can't actually list pods because by default, we're asking across the entire cluster, can she list pods? And no, she can't. But if we specify a namespace, because we only gave her access in the API namespace, it says yes, she can. Okay. And again, if we specify a namespace, it says yes, we can because she can also list those in the web namespace. But to just prove that she can't do the list pods in every namespace, kubesystem is another namespace, and no, she can't list pods there. Okay. But how do you know why? You've gone all this way and you can understand yes or no she has access, but how do you know why she has access? So in this case, there's this awesome command with kubectl. If you're ever working with any Kubernetes API, use -v8 to try and understand why. So -v is just the verbosity of the output, and by default it might be 1 or 2, but there's a level from 0 to 10. And in this case, I'm upping that verbosity so I can get a whole lot more information. And way down at the bottom, there's this response body, and that's what we actually care about. So that response body, I'm just going to zoom in, enhance this response body, and this is what that looks like. So it was a subject access review, and we're asking for, in the namespace web, can we list pods? Simple enough. And the status is allowed true. Well, that's good enough, but we've got to enhance one more time, because you see that reason down there? That's really chock full of information. I want to dig a little bit deeper in it. So RBAC is the reason it was allowed, and it was allowed by a role binding that was called Avery inside the web namespace, and it mapped this cluster role called edit to a user called avery@example.com. So that's every bit of why she has access in that specific namespace. Yeah?
Before you leave this one, why is that a cluster role? I was going to ask earlier.
Yeah.
Why is that a cluster role binding and not a role binding? Because it uses a namespace.
Okay, so awesome question. So yeah. So a cluster role is something that is available across the entire cluster. It doesn't actually mean that you could use it to grant access to a specific namespace with a role binding.
Role binding or a cluster.
Exactly. Yeah. Yeah, so I'll back up a bit. No, so it's actually something that comes out of this very verbose output, and this is really cool. So you see, when you type that command line argument, it's going to show you the request it's sending. It's just an API request. It's going to send you the request headers and the response headers, and the response body is what comes back from the API. And then all we see at the end, if we don't add all this verbosity, all this debug information, we just see yes, which is just kind of skipping all the stuff we really care about, which is, oh, I'm going the wrong direction, which is this, and more specifically, that reason. Yeah, exactly, yeah. Great questions. So the next question you might ask is, well, it's great that we know if Avery can do one specific thing, but couldn't we just have some kind of view where we could see everything that Avery could do? And luckily, because the wonders of open source, someone went ahead and created this really cool tool called Requests. And I'll have links to all of these at the end of the presentation. But Requests is this really cool tool that basically gives you this access matrix showing you everything that, in this case, Avery can do in the cluster or in a specific namespace. And this is one of my favorite tools for authorization in all of Kubernetes. So we type requests as Avery at example.com, and this is going to show her access cluster-wide. And cluster-wide, she can't really do much of anything. So you see all these X's for different things she can't do. So there's list, create, update, delete, and there's all these different kinds of objects you can modify in Kubernetes. And basically, she can't really do any of them. But if we dig in a little bit further and we say, well, what about inside the API namespace? Then we can see, okay, we gave her read access, we gave her view access there, so she can list a bunch of different resources, but she can't create, update, or delete any of them. Yeah? A blank R, it's not really something like you could list, update, or delete in this case. So for bindings, you couldn't actually, like, it's just not a possibility. And for the X's, it represents no. In this case, Avery can't do that action. And in the checkmark example, it indicates yes, she can. So that's the API example. But we gave her edit in this other namespace. So if we go ahead and move to web, you can see Avery can now do a lot inside that web namespace. You get a lot more check marks to indicate all the different things that the edit role is allowing her to do. Okay, but let's turn this around one more time and just who can do a specific action. So not with a specific user, but I'm really concerned about who I've allowed to do this one specific thing in my cluster. And there's this really cool open source tool from Aqua Security that just switches this all around for us and says, kubectl who can list pods. So it's basically allowing you to see anyone in your cluster that can do a specific thing, which is really helpful for more sensitive kind, no one really cares who can list pods. That's the least secure thing out there. But if you're talking about something more advanced, like secrets in Kubernetes, you would really care about something like this to see who can actually access secrets inside Kubernetes. So we're going to use this example of kubectl who can. And this is showing you everything. There's a lot of system components that are authorized to list pods in this example, because almost everything inside Kubernetes can list pods. It's one of the most basic things out there. But just so you know, this is a really helpful tool for that. Next, and you've gone through all these different things. You've looked at it so many different ways. Sometimes you just want to see this top-level overview. So the final tool I want to highlight in this section is a tool that we've developed ourselves at ReactiveOps, and it's RBAC Lookup. And RBAC Lookup is a tool that just says, hey, why don't we just give you a really simple open source solution to understand who has access to my cluster. And this gives you, by default, RBAC Lookup without any arguments, without any commands, is just going to show you everyone who has access and what level of access they have in your cluster. That's it. So the default output is pretty verbose. We'll take a look at what that looks like. So yeah, it shows you every single bit of access in your cluster. And this can be useful if you want to compute this or adjust this on your own, but it's fairly verbose. So a more common use case would be to use RBAC Lookup to look up a specific person. And so in this case, this is a way to see, okay, Avery has edit access in the web namespace and view access in the API namespace. Really, really simple. But one of the things you'll see in Kubernetes a lot is usernames are emails. So @example.com is a really dumb example. But let's say Avery works at a company called example.com, right? My favorite company out there. What if we wanted to do an RBAC lookup for example.com? In this case, we can see that not only Avery has access, but so does Joe and so does Sue. And then this wide output shows us where that access is coming from. So in this case, a role binding named Avery, Joe, or Sue. So that gives you this really high-level bit of information about what someone can do in your cluster, or what anyone can do in your cluster, and where that access is being defined. But sometimes, and this is going way out there, But sometimes it's not just RBAC in Kubernetes. Like 99.9% of the time, RBAC is all that matters for authorization. But Google, in all their wisdom, decided to add this extra component, which is actually really cool, but it does complicate things a little bit. With Google, you can do this really nice thing called IAM authorization as well. So you can specify in their Google Cloud IAM some really specific Kubernetes bits of access. So what we were seeing is people would use RBAC lookup, and they'd say, well, it's not coming back with anything, but I have access to the cluster, so your tool is broken. Which, I mean, it kind of was. But it was showing every bit of RBAC access, but there was also, in their case, some IAM access involved. So we added this flag called --GKE, which is Google's Kubernetes engine. And now you can see IAM access as well if you happen to be using Google's managed Kubernetes engine. So you can see any bit of access that's defined or allowed inside your cluster. All right, so that's high level how we can understand RBAC just a bit better. There's kubectl auth cani. It allows you to see if a user can perform a specific action, and if so, why they can. There's request, which basically does the same thing, but superpowers it and runs it a whole bunch of times for you and gives you this really cool access matrix. There's kubectl who can, which is aptly named because it basically says who can in your cluster do this specific action. And then there's that tool that we developed called RBAC lookup, which gives you a RBAC overview, and also, if you're using GKE, allows you to see any kind of IAM access as well. So it gives you any kind of authorization inside your cluster. And let's switch gears into our final section, and that's all about how we can make managing authorization in Kubernetes just a little bit more straightforward. Because I do think that as much as I said authorization is challenging, I think it can be simple and effective. That's what we're going to be talking about for the rest of this talk. So my idea of effective RBAC, number one, most important idea is follow the principle of least privilege. Don't give anyone access they don't actually need. And if someone doesn't need access anymore, get rid of it. Really simple. Don't need to take this to the nth degree, but just don't give anyone more access than they need. And then in Kubernetes, we have this concept called namespaces. And they're basically where you deploy similar apps together. So you might have a namespace for a specific team and a specific environment. So if you have an API team, you might have an API dev namespace, an API staging namespace, and an API production namespace. And that allows you to grant access to the API team so they can only access those namespaces. But the alternative is you could have a cluster that you just deployed all the apps into one namespace, the default namespace. That doesn't allow you to set up authorization that's meaningful because basically the most granular you can get is a namespace. So you either have access to a namespace or you don't. So all your different teams working on a Kubernetes cluster would need access to that one namespace and could modify anything inside of it. So when you're creating things, when you're laying out your Kubernetes cluster, put things in meaningful namespaces so you can then have meaningful authorization later. Yeah? Yeah. 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 Yeah, exactly. So RBAC is specific to Kubernetes API access. So things like listing pods in your cluster or creating a new container in your cluster, whatever that is, that's all that RBAC is about. There are some workloads that you're going to run in your cluster that are going to need to talk to the API. That's not common, but it does happen. That's where RBAC would matter. But for other application workloads, they usually don't need to talk directly to the Kubernetes API, so they wouldn't have any kind of RBAC access by default. Is that cool? All right, so the next, yeah. Exactly. So, well, yes, there actually are some tools that it's a little out of scope here, but there's a really cool tool called RBAC proxy that is specific for letting these Kubernetes RBAC configuration drive app-level authorization, but that's kind of a little bit out of scope, but it is a thing. It is, if you look up kube RBAC proxy, yeah, there's some really interesting workflows there. So, yeah. So the next thing that I'd say is have a clear process for your RBAC changes. As we described way back earlier on, so often authorization systems become this just kind of, well, I gave this temporary solution here, so I just granted this person access out of band, and I granted this other person access over here just because they needed it this one time. And you end up with just kind of messy access control where you don't really have a source for everything. Like, not everything is centralized in one nice place. And so you should have a clear process for RBAC changes. Even if those RBAC changes are temporary solutions, you should still have them go through your centralized workflow. And use pull requests and continuous integration to manage your authorization. And that last one is something that was pretty difficult before a tool that I'll be talking about in like 2 slides. But I think this is something that's key to a good approach to authorization. And not only should RBAC be effective, it should ideally be simple. So there are really backwards ways to manage users inside Kubernetes. There's a thing called service accounts. It was never, ever designed for this. Trying to do that is just a bad idea. Use the best practices. Use things like AWS IAM Authenticator that does the authentication for you and manages the users outside of Kubernetes. That's the way to do it. Don't do it another way and kind of hack it into Kubernetes. And don't forget that in most cases, most engineers aren't actually going to need access to your Kubernetes cluster. If you have things set up where an app is just continuously integrated and deployed into your cluster, your developers may not need access to the cluster itself. So going back to that whole principle of least privilege, only give someone access if they actually need it. And then finally, make use of those default roles that we talked about with Kubernetes. You can make some really complex roles, like that sample role I gave was list deployments, and it was already fairly long. If you want to have a generic edit role, I think it's many hundreds of lines, and it gets confusing. Just use the default roles. They're there for a reason. They work great. So we built a tool at ReactiveOps, also open source, called RBAC Manager. And the whole idea behind it was we want a better process for managing authorization in Kubernetes. And RBAC Manager, our goals were fourfold. Use more concise configuration, because that configuration gets out of hand really quickly. Group role bindings together with some kind of parent resource so they can have some structure and grouping. Automate your RBAC changes so you can actually use this process as part of a CI workflow. And then, really cool, if any of you have worked with ephemeral environments, ephemeral namespaces where you just want to spin up a copy of your app, Kubernetes does that really well. But the RBAC side of things of like, how do I set up authorization so my developers on a specific team just automatically get access to that? That's another goal that we had with RBAC Manager. So Kubernetes at its core is a really, really nice set of APIs. But they had lots of ideas for Kubernetes, and they didn't want it to turn into this massive thing, like it's already big enough, basically. So the new thing to do is to extend Kubernetes with what are called operators. So you can create your own resources, make them part of the Kubernetes API just with your own extension. So RBAC Manager is an extension, or the official term is a Kubernetes operator that extends the Kubernetes API, and this is the resource type that we use. It's called an RBAC definition. So in Kubernetes, we have this higher level resource that's called a deployment. And it manages pods, like your containers running in Kubernetes, and allows you to do automated rolling updates and lots of really nice things. So there's your low-level concept of a single container, and then you've got deployments on top of that, which do all the nice stuff for you. Role bindings were kind of like that low-level resource before, but they had nothing above them. They had nothing providing that nice level of functionality on top. So we built our own thing that we call RBAC definitions that simplify managing role bindings. And the first advantage is this is a whole lot more concise. So if you remember that example before that was incredibly repetitive, That filled up 2 slides full of YAML for our very simple use case. If we represent that same example with an RBAC definition, we get it in a single slide. So again, this is a really simple example. At any kind of scale, you're going to see more significant changes and more significant increases in scale and improvements. But for now, this is already cutting our config in half, which is a nice thing, especially as you start to scale out. So if we go ahead and apply this, our role bindings that we had before are created automatically by RBAC Manager. So these below here for the rest of this demo show RBAC Manager logs in the bottom half, and what we're doing is above. And so we can just verify that those role bindings that we had before are created automatically, but this time they're being done by RBAC Manager. So we have this kind of top-level resource managing things for us. And that's really important when it comes to a path to automation. In Kubernetes, the idea of a role binding is such that it connects a role with a user, which is great until you have this idea of, instead of, let's say, Avery having edit access, we wanted to have admin access. You can't actually make that change in place. You have to just replace, like, edit and delete a role binding, which is way more complicated and really difficult to do with CI. And then second, one of the key things when you're trying to do any kind of automation around authorization, how on earth do you automate revocation of access, and how do you do that in a safe way? Because that sounds scary. But anytime you're talking about an authorization system, you need to be able to revoke access and have what you're defining in your CI actually represent that source of truth. So in this first example, we'll change Avery's access from view to admin. And when we apply this, well, in this case, we're going to edit the RBAC definition live. I do not recommend this workflow for anything, but for a demo, sure. You can edit resources live in Kubernetes. And RBAC Manager saw that change, deleted the old role binding, and created another one for you. So it just automated and smoothed out that bit of change, because by default, that's difficult in Kubernetes. And just to verify, we'll get that role binding, and yeah, Avery has the access we want. And next, we're just going to remove that access altogether. So we're going to cross this out and say, no, Avery doesn't actually need any access at all. So we'll go back in and edit the RBAC definition again. Okay? And when we remove that, that role binding is going to get deleted by RBAC Manager immediately. So that's gone. And again, this doesn't seem that exciting, but it's really difficult previously to have done this with any kind of automation. And this smooths that entire process out so you have a path to automation. And also, it's worth saying that RBAC Manager isn't just going to delete all your roles and all your role bindings and everything like that. It only touches things that it already owns, that it created to begin with. Number 3 is simple grouping. So sometimes somebody might want to make a change to a role binding without you knowing about it. Like they may just, let's say you have a nefarious user, and they say, instead of Avery having this access, what if someone else had that access? Well, that's not great. But if you notice down below, RBAC Manager really quickly saw that change and reverted it for you. So it keeps your single source of truth and ensures that any kind of nefarious change is going to get reverted. And then even if someone deletes access, it's created automatically by RBAC Manager. So it maintains your source of truth and ensures that that stays consistent. And then we can finally just get a list of those that access and verify that, yes, Avery does have access still. That's been returned to the previous state. And finally, we have this concept of label selectors. So this is a Kubernetes native concept, and it's all about how on earth do you do ephemeral environments. Ephemeral environments are awesome for development. Like, hey, let's just spin up a namespace that can do a dev environment for you to test some feature out. This is what that's for. So in this case, a namespace selector allows you to match specific labels on a namespace. And in this case, any namespace that has a label team equals API is going to have that level of access. So when we apply this first, Avery's actually going to lose all her access because none of our namespaces are labeled at all. That's fine. We'll create another namespace, and we'll call it demo. And we'll go ahead and we'll momentarily label that as team equals API. And immediately, Avery has access, and anyone else with that label has access. And it's just really, really simple. And now we say, okay, well, hold on a second. What if that, well, verify that she does have access. But what if we want to switch that to another team? So team equals not API. I'm not very creative here, but another team, that access is automatically revoked when we switch that namespace around. So really, really simple workflow, and especially useful if you're trying to use ephemeral environments inside Kubernetes. All right, so recapping everything, RBAC Manager gives you much more concise configuration. It gives you a parent resource to group all your access together. It allows you to actually automate your RBAC changes and use CI with them. And it allows you to use label selectors to actually run with ephemeral environments, and a whole lot more, hopefully. Thanks so much for your time. I'm on Twitter at Robert J. Scott. These are all the tools that I talked about, and RBAC Lookup and RBAC Manager specifically are the ones we developed at ReactiveOps. And don't forget DevOps Days. Come join us. It's going to be awesome. Thanks.
Thank you, Rob Scott. And we have a few moments for some questions. I think you already had one.
I didn't hear you mention authentication.
You're right.
I'll posit that authorization without authentication is useless.
You're entirely right. Authentication would deserve a longer talk than this one. There is a lot going on, but you're entirely right. This completely skips over authentication. Yeah. Yeah. Sure.
All the changes you were making.
Yeah.
Where are those being?
Yeah, sure. So I usually the Kubernetes workflow would have some kind of YAML files, and in this specific workflow, I was just editing them live inside Kubernetes, which I don't recommend. Usually what you do is you'd have a repo that has, in this case, an RBAC definition. You'd make a commit to it, and that would go through some kind of CI process, a pull request, someone else would approve your change, and then it would actually get applied to Kubernetes. So it would, ideally, all this config would live in a Git repo somewhere. So, yeah.
RBAC definition, is that
Yep.
right? Is a Kubernetes operation, is that right? Is that the right term?
Very close, yeah. So RBAC Manager is a Kubernetes operator, and you can define custom resources that operators manage. And RBAC, yeah, so yes.
Does that mean I can use it in Helm?
Yeah, you could use
Just be automatically recognized as long as it's installed and all that?
exactly that. Yeah, yeah, yeah. So we provide a way to install that with Helm as an example, and it just works. So, yeah. And Helm is the Kubernetes package manager. So if you think of something like apt-get, but for Kubernetes, Helm. And you can create your own packages for it, and lots of people deploy their applications with Helm. Cool, I think that's it. Well, thanks so much for coming out. Definitely, if you have any feedback, any things I can improve, let me know. And yeah, thanks for your time.
Round of applause for Robert Scott. And remember, next week we are not here. We are going with the Center and UTC for that special event. But we will be here the following week, and we have a call for speakers. So if you want an opportunity to give a talk here at ChildDev, reach out to one of the organizers, and we'll help get you scheduled. Thank you.